Hey guys, okay, so here's today's notes. We started this problem before we left, and I was going to post a solution, but I figured I'd go over it with you. Did not expect to be in quarantine. Okay, so the question says carbon monoxide is often used in metallurgy to remove oxygen from the metal oxides and thereby give the free metal. The thermochemical reaction of the carbon monoxide with iron oxide is this one here as follows. Okay, so iron oxide or iron 3 oxide reacts with carbon monoxide to form 2 moles of iron and 3 moles of CO2. That has a heat of formation of negative 6.39 kilocalories. Now, using this reaction here, okay, we basically have to end up here, okay? So kind of go back to your notes, and basically we got to kind of add these two reactions, right? Because the total reaction is the sum of these two, and we need to end up here. So that's, I think, what we were having a little bit of a struggle the last time. So we're going to go over it real quick. All right, so let me scoop this up a little bit. Okay, so the first thing we're going to do then is we're going to go ahead and we're going to combine these, okay? Now, I want you guys to pay attention to something real quick. All right, in the reaction, you see that the iron 3 oxide here is actually a product. So let me go ahead and get my red pen here, and you're going to see that this is actually a product. Okay, so there's a couple of things we got to pay attention to. One, the iron 3 oxide is a product, and in this reaction, it is a reactant. Okay, and the other thing too is I want you to pay attention to the carbon monoxide, because you see how we have carbon monoxide here and here, but the number of moles don't add up. This is 3 moles and this is only 1 mole. So there's a couple of things that we need to pay attention to. So first things first, because iron 3 oxide is a product, what I'm going to do is I'm going to go ahead and flip this reaction. Okay, so I'm going to flip reaction 1. Flip reaction 1. Right, and the reason I'm going to do that is I'm going to do that so my iron 3 oxide is actually in a product instead of a reactant. Okay, so all I'm going to do is I'm going to rewrite this just in reverse. Okay, yields, and in this case it's going to be iron 3 oxide solid plus 3 moles of CO2. Sorry, I was looking at the wrong thing there for a second. Okay, so we have that. So we flip this one, and then we're going to combine it with this one here. So CO gas plus 1/2 O2 yields CO2. Okay, this has a heat of formation, okay, is now going to be opposite because we flipped it, right? 6.39 kilocalories. All right, so the number stays the same. The only thing that we removed was the negative because it's now the opposite reaction. So instead of being exothermic, now it's going to be endothermic and it's going to be absorbing energy. Okay, so here we have our reactions. Now, the other thing I told you guys to pay attention to was the number of moles, right? So this one has 3, and you can see that there's CO. Let's see, did I write this correctly? Oh, that's supposed to be, yeah, I thought so. There's CO and there is CO2, right? And they're on opposite sides of the arrow. See how the CO is here and the CO is here and the CO2 is here and the CO2 is here? That's what we want because now we can cancel. The problem is that we can't cancel these because there's not enough moles on the bottom, right? So what I'm going to do then is I'm going to go ahead and multiply the whole reaction times 3. Okay. When I do that, okay, I'm going to rewrite this here. By doing that, then I get a whole new set of reactions, right? So let's go ahead and do this one more time. Put this one in black. Okay, so I'm going to rewrite it. There we go. CO2 gas produces iron 3 oxide Okay, and now this one's going to change. So now I'm going to end up with 3 moles of CO gas plus 3/2 of O2 gas to produce 3 moles of CO2 gas. Okay, now that does a couple of things, right? So first and foremost, we already said that this sign is going to be opposite, so 6.39 kilocalories. Okay, and since we multiplied the whole reaction by 3, well, now the heat of formation, right, of our first reaction, let's see, put it down here, it's negative 67.3. My mouse is in the way. 67.63 kilocalories. Scroll this all the way up. Okay, this also has to be multiplied by 3, right? All right, so let's go ahead and get that real quick. Okay. So now the heat of formation becomes negative 202 kilocalories, okay, of energy. All right. So what does that mean here? All right. So here's our sum of reactions, right? Now remember that when you have a reaction that happens in steps, then Hess's law says that the sum of the energies of each reaction is equal to the total amount of energy for the overall reaction. So what that means is basically all we got to do is add up, if this is step 1 here, and this is step 2 here, then we add these guys together to get the total sum of the reaction. Okay, so let's go ahead and add these up, but first let's go ahead and cancel everything that's the same. All right, so I'm going to cancel this one because we have 3 moles of CO here. We have 3 moles of CO here. We have 3 moles of CO2 here. We have 3 moles of CO2 here. Okay, so those are the ones that are the same on both sides, right? So if we're going to rewrite the reaction, then this becomes 2 moles of iron solid plus, plus 3/2 of O2 gas yields 1 mole of, iron 3 oxide solid. Okay, so if you take a look, right, I'm going to scroll this up. That's exactly the reaction that we should have ended up with. See, it's right here. So that's how we get that reaction. So now we figured out that reaction. Now let's calculate the amount of the energy of formation, right? So to calculate the total, right, the total heat of formation, then I take negative 202.89 kilocalories, and then I add that, right, to 6.39 kilocalories. All right, and I should end up with a total heat of formation of negative 196.5. All right, so in this reaction, right, the heat of formation of iron 3 oxide, or the iron here in this case, is going to be right here. And we just did that using Hess's law, saying that the sum of each step of a reaction is equal to the total. All right, so that's how we do the problem. If you guys have any questions, feel free to reach out to me on Google Class, okay? Or text me.